Velociraptor team for a while now. And actually, if I just give you a quick summary of Matt here, he's an endpoint and threat-focused practitioner who currently works in the threat analytics department at Rapid7. He's been an early adopter of Velociraptor and has been working with the platform since version 0.2x, which I think is like just under 5 years, right, Matt? Something like that.
Yep, that's a really good intro. Thank you, Carlos.
So, Matt, take it away. The floor is yours.
Cool, thank you. I think you just need to stop sharing. There we go. Okay, bear with me. Okay, can you see that, Carlos?
Looking good. Thanks, Matt.
Yeah, awesome. Okay, so for this talk, I've kind of left everything in slides, which would be an interesting experience. My talk's probably going to be just under 30 minutes, I think, depending on how much I waffle. So hopefully we'll get a little bit of extra time back when I run through this. But it's titled Velociraptor Content Like a Boss. First of all, a little bit about me. My name's Matt, and I work at Rapid7, as it was just announced. I'm into DFIR detection kind of stuff, and my claim to fame is I am an early Velociraptor adopter. The specialty I'm bringing to this talk anyway is I do lots of consulting IR deployments, and I think this description or this talk is something I would have liked when I was first starting out setting up Velociraptor. I never really had a DevOps team, and I had to do all this kind of stuff myself. So hopefully people will get value from the talk with that. The agenda for today is I'm going to talk about content management, obviously. I'm going to start really slowly and give some background on like the why of content management and how we update. I'm going to kind of show you how we used to do it, which I'm not sure how many people know how kind of manual the process was. And then I'm going to kind of introduce Detect Raptor and give an overview of that. I'm then going to talk a little bit about the concepts and automation. And like I said, hopefully give you some ideas on how you can use these techniques in the field. So first of all, why content management? Now, this picture on the right-hand side is a picture that I've used in other slide decks before, and I think it kind of says what Velociraptor can do in a single image, right? Velociraptor can do so much so that for new users, it's a little bit disconcerting sometimes, where they don't necessarily know what keywords to search or what artifacts to run. So that's kind of the first big benefit of content management, is it lets you kind of run your own gear and standardize a workflow. And that could be workflow where you've got your own custom cape kind of artifact that you run, or it could be something very specific that you build your own context, but you build your own content based upon like threat intelligence and things like that. It's really up to your environment. We also have the option of doing things like versioning. So I contribute to the main project, and often I want to run that artifact. And the only way I really have to run that automatically across a whole bunch of environments is with content management, by deploying it out to servers automatically. So I don't need to go across to every box and kind of add things manually. So it really helps with that. And it's a similar story if you don't necessarily want to update straight away, yet you want like newer content, or there could be a slight tweak in content with the server that you're running. It really helps with versioning. Reduced deployment friction is an interesting point I don't think many people think about, where I kind of see like tech deployment as being really core to IR. And it's the most frustrating thing in the world, where you're waiting to deploy something, and even worse when the customer has to wait. And we can kind of alleviate like some of those issues with content management. That could be maybe building an offline collector, building an MSI automatically. It just is much nicer to do the work ahead of time and front load it, and then have the content created automatically for you. The second last point there about Git is something that I'm pretty passionate about, where a lot of people might be a bit uncomfortable to do a pull request into the main project. And if you've got like a private repo and the people to support it, you can really get some skills uplift with people learning and getting some good feedback if they don't really want to go public straight away. And finally, threat intelligence. I think I touched upon that before. To be able to consume intel and use it effectively everywhere is a really good use case as well. Essentially, we're looking to go from that kind of noisy slide to this situation that I'm sure people are familiar with when you run Velociraptor. Okay, so first of all, we'll go really slow and we'll talk about custom artifacts. So if you want to create a custom artifact, most people kind of know about this plus button, and then you're presented with the custom artifact view. Hopefully you're going to create an artifact that's a bit better than select star from info, but say you save that, it saves it directly to the disk. And what you can see on the screen is me on a Velociraptor server, and I'm just catting the artifact, right? And you can see the bits that I've highlighted is the data store, the definitions folder, and where the arrow is pointing is the artifact name and path. And you can kind of see it's just in a folder, and then the name of the artifact.yaml. And actually that was kind of how the old way of artifact management would be, right? You can kind of see in the middle, I've got a manual copy definitions, and literally, let's see if I can get my pointer. Literally, this is kind of similar to a deployment script that I used to run. The thing to kind of keep in mind, like this still works, by the way, but the thing to keep in mind is this part here. You need to restart the Velociraptor server, and that's kind of painful. And even with running this command as well, just pointing to a definitions path, the core problem is you still need to restart the server. Essentially, that's why Mike eventually implemented a VQL method, and things were happy. And this is what I'm going to kind of walk through now. Most people are kind of familiar with the artifact exchange, and it's kind of like, I think, the standard for artifact management. And essentially, it's a server kind of artifact, and we have a couple of parameters and a prefix here. The URL is essentially just a zip file that's publicly accessible via zip file. And then when we move along, you can see on the left-hand side, we have the disk view. And then on the right-hand side, we have what we see in the GUI. Symbols or regex here to get that same kind of view as the disk version. But you can kind of see that artifacts are on the machine. That kind of happens with essentially two functions and a plugin. And I'll kind of walk through kind of how we do this here in the artifact exchange, because this is kind of how simple it is really. Essentially, we have a HTTP client function that we can download the zip file with. And then we use the zip accessor, and we essentially glob for any YAML files inside that and then read them. And then finally, we set the artifact with that data that we extract. And it really is that simple. And you can kind of see the view that you'd get when you import from the exchange here, right? So really simple stuff. Similarly, we can delete artifacts, and it's a very similar kind of artifact, where in this case, we have down here the plugin for the artifact definitions, and we have a where clause for not built in, and that's pretty much just to stop errors. But we're taking this artifact regex at the top, and then we're using a filter for one of the fields we're extracting, name, from this plugin. After that, we essentially have like a confirmation item that you can just view, or if you really want to do it. And very similar to the artifact exchange, you can delete artifacts this way. And this is so much easier than using the GUI to be able to manage artifacts in bulk. And anything that you might want to do in terms of artifact management, you can kind of do using similar methods. I thought I would just print out some of the fields in the artifact definitions plugin to give you an idea. I don't really have much to say here. It's kind of self-explanatory, the sections, but what I want to highlight here is the built-in field here. And this is a non-built-in, but I've actually named it like a built-in artifact. And that's something to keep in mind, that you don't actually need a prefix. You can call artifacts anything you want in the more recent versions of Velociraptor. So it's always a good idea to use that built-in flag if you're kind of like messing with non-built-in artifacts, just to see what's out there, just to see that the user hasn't like created a short name or something that you're not aware of. The other thing I wanted to point out was, I think there was a question I read a little while ago about aliases, and this is how you can add an alias to an artifact. You simply add a heading aliases and then add what you want to have as the alias. In this case, we've got a generic network interface, and we want to add a Windows specific to that. You could also add like another dash and add Linux or Mac or whatever you wanted. It's a very generic artifact. But when we run that, you can kind of see it just adds another artifact, and then it just sets that is alias flag to true. Kind of simple. Okay, so we've gone over a summary. I've gone through the simple stuff with content creation and deletion and a couple of interesting features. I'm now going to talk about DetectRaptor and get into what I think is probably more interesting for people. Now, DetectRaptor, pretty much was a proof of concept that I wrote maybe a year ago to kind of show how we could generate artifacts for bulk Velociraptor detection content, focusing on like publicly available like artifact, ISCs and things. Essentially, I publish like a zip file here as a release, and the repo is updated kind of automatically every time there's a change really that's relevant. I'd like to point out like some of the contributors down the bottom. So you've got me, who wrote most of it, and it's kind of my repo, but Michael, who I worked with at Rapid7, and Zach, who I worked with at CyberCX, SVC host. A lot of this stuff is the kind of things that we've been using for years. And it's kind of like us messing around, and the content's changed a lot as we've moved ahead to make it more performant. But it's the same kind of ideas that we've been using for a very long time to optimize running VQL queries. Like I mentioned, there's several bulk artifacts, and it's published as a zip, as a latest release. And the example I'm going to walk through is Windows Detection MFT. Now, this particular artifact, I think it's interesting because typically MFT kind of hunting and artifacts can be very heavy, but I've done a lot of work to optimize this artifact. And it's a really good example of kind of customizing things to your workflow. And at the end, I'll show you some really cool notebook tricks as well that we've implemented. So the first thing I want to point out is this kind of resources configuration. So in this case, I've just configured kind of the timeout to 9,000 seconds because it is a big hunt. But I'll show you how to configure this like automatically later, but it's good to keep in mind that you can just set this in an artifact. We've also got parameters that are useful for workflow here. And specifically, one that I like that I've just started using is this criticality level, which can help you optimize your hunts with performance even more. And then the third part on the screen is the ISCs and context section. Now, ISCs is pretty big, and I'm not going to go through all of them, but I've extracted a few to kind of walk through some of the ideas. Now, just to note, like this is just an example, and you can kind of create like a CSV or an artifact that has anything here. But this is just kind of what I've used for this use case because I found it effective. But you can kind of see we've got the name here as detection. If you guys know the MFT, essentially you've got like an MFT object, which is typically a file name or top-level folder name. And when you search the MFT, it's very efficient to search for that top-level name. And that's what the keyword regex search is for. When you're searching for, say, a path, you essentially need to enumerate the path of an MFT record. And that can mean lots of MFT records go into that. So that can be heavily resource intensive. So ideally, you're going to have a first pass that runs with this keyword regex. So you can kind of see at the top for data transfer, megasync is a pretty unique string, right? So you don't need to worry too much about that. Mega.exe, we've kind of anchored the mega part at the start of the string to make it a bit more efficient. Whilst at the bottom, the suspicious location, we're looking more at kind of extension, right? So that's going to pull back all executables or all DLLs, et cetera, et cetera. In this particular line, we're looking at having that second pass regex here of path to make it an effective detection, right? But in terms of performance, these top three are going to be much more performant than this bottom one. The third option here, or fourth, is ignore regex. And essentially that's like a whitelist that we can ignore things with. And finally, we have reference and a criticality for performance. Right? And I'll say it again, this is just an example, but you can kind of configure any kind of thing. And what I think is the value of showing this is it will give you ideas of how you can do your own kind of automations. When I move along, now this is kind of the guts of VQL. And I tell you, I have stripped out a lot of VQL out of this demo, so I'm trying to limit it as much as possible. But essentially the first part here is we materialize ISCs. And again, this is a performance thing. And for people that might be new, materialize is this little kind of less than equals sign where we essentially put all the ISCs in memory. So it's really fast to look it up. We also remove keyword regexes. So anything that's accidentally gone in with a kind of an OR, we remove that because you don't want to be returning like a million MFT entries as a first pass, which kind of sucks. But then we've also got the option of using that parameter for criticality and being very targeted with only looking at, say, critical or high items. As I mentioned, we've got a first path. And in this case, we're just searching for the top level MFT name, right? File regex, but we're calling the Windows NTFS artifact. So we're using artifacts that already exist, but just kind of pulling out and querying what we want effectively. With the second pass, we're taking all of our hits that we pulled from the first path, and then we're running them through all of our ISCs and then doing our full filter. Interestingly, we're only returning one entry, and again, that's performance. And up here, I'm creating a dict that has all the detection context in it. And this is the results that kind of come back, or an example of results. And you can kind of see the bit that's highlighted now, we have an exe in suspicious location, vdump.exe in the public folder. And it's really cool because essentially I've built this artifact to kind of show me what I want to triage quickly. We've got information on the hit and then other things that are pertinent to this artifact, like timestamps and size and things like that. And from here, typically I'd pivot off and ask other questions, but this is an example of like taking artifacts that exist and kind of adding a calculator and doing kind of what you want. And the second example I've got is Spring Connect, which is an RMM program. And again, the idea of this artifact is to just have things bubble up to the top. It's not meant to be a perfect kind of detection thing. It's more what's interesting on the box that bubbles up to the top. Okay, so the next thing I want to cover out is notebook suggestions. And on the right-hand side, you can see me continuing the VQL of this MFT artifact. So you can get an idea of some of the VQL. And in the main picture, you can see kind of the path that you see this. And what notebook suggestions are is they're kind of like a workflow tool where you can append kind of set notebooks to an artifact. So when you're in the notebook and doing review of the results, you can click the little plus, you can then click suggestions and have a pre-built notebook ready to go. So in this case, we've got a detection summary that you can get a nice little stacked summary of all of the outcomes that have come from the box. And I've also got a list here showing critical and high items. So like I said before, able to bubble things up very quickly. Someone that might not necessarily know how to use Notebook can get some interesting results. And the cool thing is you've got the notebook template, so you can mess with it if you want. It just saves a lot of time typing. And I find it's a very effective way to deploy artifacts, to have this pre-built notebook ready to go for users. So in summary, we've got a whole bunch of artifacts in this repo that kind of do a similar thing, that build similar capabilities. And then we publish them out to a zip. So hopefully you're familiar with that. I thought I would cover off some of the CSVs that we have. And like I said, these are kind of things that we've used for kind of years, and we've kind of updated them as we go. The event logs one is interesting to look at, where it's a series of event logs, but it's the same kind of idea where this CSV is built to be quite performant, in that you can see I've got a column that has event log. I've got a column that has event ID and then raw, and there's also ignore lists, etc., and context ahead that's off screen. But the whole idea is we run a query and then we use these fields to be very targeted in our collection. We're targeted so much that, like, from a performance viewpoint, a lot of the time if you're running like EVTX Hunter, it can really chug down. But by using some smarts like this, it really improves performance somewhat. The other thing that's kind of interesting is these PowerShell entries. So if you go back and have a look at some of the other artifacts, I've got things like looking at PS read line, looking at like PowerShell ISE remnants. And what we do is we have a script that will pull out these ISEs and then apply it to those artifacts as well. So we're not just limited to like PowerShell event logs. We can leverage these in other artifacts. And this is the beauty of kind of automatic artifact generation. You're kind of only really limited to what your mind can think of. Okay, and this one, I accidentally left this in, but okay, so this one is the version information that we run in our binary rename artifact, and it just has a whole bunch of like file names and internal and original names, and we run this. It's actually very similar to the artifact that we have in the main repo, but it gives us a chance to, like I said before, version out things and add things early before we push them into the main project. So how do we generate artifacts? And this slide is introducing the scripts folder in GitHub. And you can kind of see there's a whole bunch of Python files, and I'll kind of show you how that works a little bit later. But the other side I want to introduce is the templates of each artifact. So in this case, I'm showing binary rename artifact up here, and it's exactly the same as the published artifact, except we don't have any indicators or any interesting things in it. I've just got a string that I'm looking at popping all of my indicators in, right? And this is the beauty of automation, because it means that we can edit essentially a single point and then have all of our artifacts built automatically. In this case, I'm using GitHub Actions, and you can see the workflow file that I've highlighted. But say internally at Rapid7, we use other automation tools. And I'm sure if you've got a DevOps team, you probably, or they are probably already doing similar techniques and you're using something like this, or it'll be really easy to have them help you out, set this up. I use GitHub because it's really lightweight and it's something that is kind of free. And because I don't need to worry about authentication because I'm in a public setup, it's quite easy. But you can see in blue, essentially we're installing the prerequisites, which is like setting Python up. So really straightforward. And then we're running our Python scripts. And like I mentioned before, we're taking the CSVs, we're merging with the templates by using that split me. And then we're kind of publishing those YAML files back into the project and generating that zip file. So it's really simple. And like I touched upon before, if you preload a lot of work, when you get to a stage of doing engagements, it's super amazing to have all this great content there ready to go. It is like the guy loving the Velociraptor picture that I showed before. So how do you deploy Detect Raptor? Now, I use an artifact called server import Detect Raptor, and this is actually on the Artifact Exchange now. Like I mentioned previously, I would actually use the same method as the artifact exchange and I'd use a zip file. But I've recently, last weekend, I updated it to use this API link in GitHub. And this is super cool from a performance viewpoint, because I'm going to show you next how to do some monitoring and automatic updating. And what this enables me to do is kind of optimize, save resources when I'm updating. But say when I import it, you'll get a list of SHA-1s, and then we can compare those SHA-1s in the build script that I run, just to make sure the content is updated successfully and everything's working. As I mentioned, part of the deployment is validation, and you can kind of see at the back we've got like a JSON thing. That's actually the URI for the releases that I showed you before for the artifact. And when I run the artifact, it actually adds some server metadata to the server, which is a way of kind of storing this last updated time. And then I also kind of take a hash of the zip file. So we've got a way to validate whether or not the content is recent or not. So how do we automate deployment? We've already got server import detect raptor, but what we can do is use a server monitoring artifact, or we can do like a server schedule to essentially monitor for new content. And what I use is an artifact called server managed content, and you can kind of see at the bottom, I am setting that up in the little I, which is the server kind of server events section. I'm using a schedule of 14,440. That's actually 4 hours. But what you can see highlighted now is all this artifact does is essentially at a schedule that you specify, it runs that same artifact. Really simple stuff. When I run that as a schedule, this is the logs. So you can kind of see the bit that's red. I'm fetching that API URI up here. And there's no kind of requirement to download it because the server metadata matches. But the blue, the server metadata is different. So you can see it hits the API, it then downloads the zip, and then it installs and updates the metadata there. And then it just goes on and on and on. I actually set this to every 10 minutes, I think, to run, just so I could demo it and get a screenshot for everybody quickly. But it's really cool. When this works and it's deployed, it's an amazing workflow. It means that I can just go edit my CSVs or edit if my script is reaching out to like a CTI platform, I can edit that and then just have everything update automatically. It's a magical experience. Here's the output again. So this is very similar, exactly the same as what I showed you before. And just with the validations of the SHA there, I found that to be helpful, but it's not really needed. It's kind of up to you. Okay, so next I want to touch on is hunt automation. And in Detect Raptor, we have a capability called Start Hunts. And what it does is it lets us run hunts by name. And by default, like this is one of the artifacts that I build automatically, and it automatically populates all of these names. But you can add in whatever artifact you want here. It's not really set in stone. All it's doing is looping through these artifacts. If you notice before in the MFT artifact, I actually had a prefix, artifact dot, and then artifact name. We don't actually need to use that here because the artifact does that when it runs the hunts. But in this case, you can set the artifact, you can set the resources. So I showed you the resources in the MFT hunt, and this will actually override the settings that the artifacts have by default. So you can kind of see here in the MFT, I'm using 9001, and then I'm using the IOPS limit. This is another talk in itself in terms of performance and hunting. But when you run bulk artifacts, I would really recommend thinking about performance and how it's going to impact your customers. For instance, sometimes there's customers that we just don't run hunts with because they might be really sensitive, or we might stick to maybe memory-based artifacts because we know they're going to be a lot more lightweight than heavy disk-based stuff. The thing to touch on is they are paused by default. But if you go back, you can kind of see up here, there is a just run. There's also a just targeting, so you don't need to mess up your hunt screen with a whole bunch of paused hunts. There's lots of flexibility with what you can run. You might have like a set pack you want to run every time, all the time, but others you want to keep paused so you can control when they run. Something else that I use regularly is I'll run an artifact pause like this, and then I'll just go and hit this copy button and then re-edit the config if I want to mess with it. And I find that works pretty well for a quick fire change. Okay, so what's next for Detect Raptor? I pretty much haven't done a huge much to it, but I want to kind of bring on more bulk open source themes, right? I've got a whole bunch of Yarra implementations where I build like Yarra artifacts automatically. So I plan to add them in with a bunch of open source kind of sources. I need to refactor some of the projects that are in there already, like lol drivers and hijack libs. So if you've actually looked at those artifacts, they're pretty big, and some of them have they've changed the format. So some of the entries are messed up. It still should work, but it needs improvement. I also want to implement bootloaders.io because we have some really interesting content with bootloaders in Velociraptor that a user has put in. It's actually in Velociraptor 7 that I don't think it's been publicized too much, but yeah, there's a lot of opportunity there for bootloader-based detection. So I plan to play with that a lot. And also any other PRs that people might have or any other good ideas, reach out and we can have a chat. So in conclusion, I think like I've only just kind of scratched the surface of content management. Like there are many, many ways to add value to your deployments. I've really just shown like a little bit on how like automation and VQL can make things really easy. And like I said, reach out for any collaboration. We accept pull requests. And if you want to share indicators as well, we can look at like doing some sharing stuff and any other ideas you might have. Down the bottom, I've added links, and I will share this slide deck a little bit later. And I'll leave you with this guy. Thank you.
All right. Thanks a lot, Matt. Great presentation as always. If anybody has any questions for Matt, go ahead and throw those into the Q&A chat at the bottom there. There's a little Q&A icon. You can ask him, just type those in right now and we'll try to get them to it. There is one question in there, Matt, if you want to tackle it. Looks to be a VQL related question. For VQLs such as IOC inside MFT detector, and this might be a question better for Mike, but for VQLs such as the IOC inside MFP detector, do you plan to implement a service that provides IOCs such as ISSP, MISP, or OpenCTI?
Yeah, exactly. So for what I showed you in Detect Raptor, probably not, but yes, in short, yes, we do have artifacts that can do that. So yes, it's really quite easy. If you want to look at an example of like how to pull down a web, so like building the artifacts, the examples I've used are just Python, right? So you can go and have a look at maybe have a look at the hijack libs or the lol drivers one. And essentially what I'm doing is I'm reaching out to their site and pulling down like essentially a JSON that I'm then filtering and building an artifact with. So it's simple. Yes, in short.
Excellent. Yeah.
And yeah, Robert, like, yeah, you can just like fork it and like steal it, mate. Like that's the whole point. It's on the internet and it's open to everyone.
I got a couple of questions in there as they're coming in. This is a little, maybe a little too vague. Is this already integrated in Rapid7 solutions? I don't know.
Yeah, like, so I would say I would influence some of the Rapid7 solutions. I don't think they would copy my public shanky stuff, but yeah, like not this exact detection, but I think that, yeah, we would definitely be looking at like implementing stuff. And for example, our IR, we use some of this stuff, some of these queries as well. We filter them. The whole idea is our IR team are experts in Velociraptor, right? So we use a lot of content from a lot of places and deploy them like with expert knowledge.
Got it. And then Robert Wiebner is asking, if I want to build my own Detect Raptor workflow, can I take the Detect Raptor workflow as an example?
Yeah, definitely. 100% open source.
Great. All right. Matt, I think you're off the clock. Thank you very much.